Hello everyone and welcome to the Well of Curiosity. This will be the 4th episode of the Volcanologist Guide to the Solar System, the series that is dedicated to investigating volcanoes both here on the Earth and beyond. In the last episode we were taking a look at the different types of volcanic eruptions. If you've missed that or any of the series then please do check them out. But for now, we are going to take a look at the different types of objects that will be heading your way during an eruption. To begin, let's take a look at the big one, lava, the molten rock that spews out from inside our planet onto the surface. Although much thicker and stickier than water, it can still flow over the ground under the influence of gravity, as long as the temperature remains high enough. Different volcanoes can produce different types of lava, which can vary in their temperature and composition, which can affect how far they can flow. Generally, the cooler the lava, the thicker and stickier it will be, and therefore it will move much more slowly and it won't be able to flow that far. The hottest lavas can be over 1,200 degrees Celsius and are quite runny. They've been seen to move at over 30 miles an hour, so if you see one heading your way, you better start running early. They can flow for tens of kilometers before cooling into a dark rock called basalt. The lavas can be split into groups based on their appearance as they flow and begin to cool, with each having its own specific texture. Pohoihoe is formed by very hot lava and advances quickly as a series of lobes called toes. It has a ropey texture to it and is formed by the surface of lava cooling to form a thin, pliable skin whilst remaining hot and mobile inside. A'a is a bit cooler and a bit thicker than Pohoihoe. It has a very rough, fragmented surface and can still advance quite quickly. Pillow lavas form when a volcano erupts underwater. The water cools down the surface very quickly, but the lava remains molten inside and continues to move and expand, creating large bulbous rocks. Block lavas are relatively cool for a lava and very thick, producing short, stubby flows. When the lava eventually cools, it forms smooth, cube-shaped blocks. So apart from lava running across the ground, what else is there? Well, during the more explosive eruptions, a multitude of objects can be fired into the air, from harmful gases like carbon dioxide, carbon monoxide and sulfur dioxide, to solid objects known as tephra, which can be split into a variety of groups based on their size. Ash is made up of the smallest particles that are carried upwards as a plume and can be carried for hundreds, if not thousands of kilometres, eventually falling back down in a dust-like layer. Often the ash rubs together and builds up an electrical charge that can produce huge bolts of lightning, kind of like rubbing a balloon on yourself and then getting a shock when you touch someone or something else, just much bigger and much more violent. Cinders are slightly bigger than ash and are teardrop or button-shaped pieces of rock that are thrown out and can fall in showers up to 25 kilometres away. Lava bombs are bigger again and consist of blocks of lava that can be boulder-sized. The larger ones can be solid around the outside but still molten in the middle and can be launched up to 1 kilometre away from the volcano. Some tiny pieces of the lava can be thrown out into the air and be spun by the wind to form a strange, glassy, yellow material that resembles hair and is known as Peles hair, after the Hawaiian goddess of volcanoes. If lava is cooled really quickly, by landing in water for example, then it can form a smooth, shiny glass, such as obsidian. And if the rapidly cooling lava contains lots of gas, then that gas can remain trapped inside as lots of little bubbles. The rock that forms from this will end up being very light, full of holes, and is referred to as pumice. One of the more dangerous products of a volcanic eruption are the fast-moving flows of hot gases, ash and rock that can barrel their way down the side of a volcano. These are pyroclastic flows, and are most often caused when an ash column collapses or when the volcano erupts from the side rather than the top. They can move at around 100 kilometers per hour and will flatten and bury everything in their path. Finally, if all of that wasn't enough, volcanoes that erupt in areas with large amounts of water, like lakes, rivers or glaciers, or they erupt in an area with a high amount of rainfall, can result in the ash, rock and other debris mixing in with that water to create a mud flow or lahar. These are large, fast and very violent, travelling at up to 100 kilometers per hour, resembling wet concrete, capable of ripping trees out of the ground, carrying away houses, boulders, cars and people, and burying huge areas of land in very thick mud, which is very difficult to escape from. These mud flows have been seen to bury entire cities. So far in our journey, we have taken a look at what fuels our volcanoes, the different types you can find, the kinds of eruptions that they produce, and the range of objects that are thrown out during those eruptions. I do hope that you've enjoyed this particular episode. If you have, then give it a like and subscribe to the channel if you're new. Join me next time when we take a look at some of the more famous volcanic eruptions that have occurred during the history of our planet. I hope to see you all there. Goodbye for now.